Hey there, welcome back. Here we have another question. Let's get ready right away. It's question 56. This question is also one of those that belongs to that group of questions I gave you in your Apollo book. That first set of questions, right? So this question's a bit different from the first one that we did. This one's different because it's a let statement question. So let statement questions are, they're questions you'll often see in algebra. They're going to say, let x be some number between 1 and 50. And then they'll go on to give you something with x in it, like x over 200. And then they might ask you, which of these, when divided, gives you an integer or an even integer. Questions with let statements basically mean you have to think creatively. You have to really imagine what they're asking you to imagine. So that's what we'll do here. And what it's asking us here, it's let letter H stand for a non-zero digit. The 3-digit number, HHH, is always divisible by which of the following? Let's reread that, and then this time, write down what's important. Let the letter H stand for a non-zero digit. So let's look there. Non-zero digit. The 3-digit number, HHH, is always divisible by. Now, you should never do mental math, and you should never let yourself think about numbers that abstractly. Let's actually work with numbers we know, because numbers are already abstract. Why make them more abstract? So, what do they mean by non-zero digit? Really, they just mean any number like 1, 2, 3, 4, 5, 6, 7, 8, 9. In fact, they don't mean a number like that. They actually mean those numbers, because you can't include the number 10, because that wouldn't... H is just a single placeholder. If 10 occupies 2 spaces, see? So 10 can't be a candidate. It has to be a number that occupies just 1 space, since that same number, since that same digit, is going to be appearing 3 times, side by side. Alright, so what candidates do we have? It can't be 0, because they say here specifically it has to be a non-zero number. So basically it can be any number from 1 through 10. That means 1 through 10 inclusive. So let's give it a shot. Now, we can't possibly do 1, 1, 1, 2, 2, 2, 3, 3, 3. We don't have enough time for that in the real, during the real test. So what we should think of is, what is the difference between all those numbers? Some are odd and some are even. That's the first thing that should pop into your head. Because really, when you scrutinize numbers, when you look closely at numbers, numbers could either be odd or even, or they can be prime or composite. But let's give it a shot with odds and evens first, and then primes and composites. I'll tell you why really we can't use a prime or a composite in another video, because questions that involve thinking about primes and composites usually have to do with factors or with multiples, and this isn't that kind of question really. Alright, so let's look closely and I'll explain later in another video. Let's start by thinking about all the numbers again, but really just thinking about odd and even ones. So let's think about the number 2. That'll be our candidate for an even integer. That's non-zero, and that's single digit. And then our candidate for the odd non-zero digit will be 3. So H here is 2, H here is 3, and let's get going. They want HHH, which means they want 2, 2, 2. And then here's our odd one, 3, 3, 3. Now, which one of these numbers can go into both of these without a remainder? Can 2 squeeze into both of these without a remainder? Can 3 squeeze into both of these without a remainder? Can 5? Can 11? Can 13? That's our task, alright? So let's get going. First, we'll start with this one, 2, 2, 2, right? I'll put these numbers right here. Alright, so I hope my hand doesn't block it too much. I just really don't have that much freedom. Let's start 2, 2, 2. And obviously 2 does go in there, right? See? Ah, good. So it looks like it has a chance. But then, when we do this, does it work? So, let's do the long division. How many 2's are in 13? 6 times 2 is 12. We have 1. Drag it down. That's 3. How many 2's are in 13? 6, 12, and nope, it's going to end up giving us some kind of remainder. So 2 doesn't qualify. Why? Because though it squeezes into 2, 2, 2, it doesn't squeeze into 3, 3, 3. So let's try again, this time with 3. So this would essentially be the kind of question you plug in for. And it's all about knowing how to set it up. So we're done with the setup, and now we're just trying out our candidates, which are our multiple choices. So this time we'll do 2, 2, 2, 3, 3, 3. Now, if you were taking a test, like if I were doing this, the first thing that I would do is try 3, 3, 3, because obviously 3 goes into 3, 3, 3. That's not even a question. Obviously the answer is like that, right? So we already know that one's approved of. It's this one that we have to think about. So I'm sorry. Let's go like this and go like that. How many 3s are there in 2? None. How many 3s are there in 22? So it's 7. 7 times 3 is 21. You subtract. There's 1 left over. And then, of course, you bring down that 2. How many 3s are in 12? 4. It went in cleanly with no remainder. What does that mean? It means that 3 can squeeze into both 2, 2, 2 and 3, 3, 3. And it can, in theory, squeeze into 4, 4, 4 and 5, 5, 5. Because what's 4, 4, 4? It's just another 3-digit number that's made up of 3 even digits that are the same one as the other. Same is true with, say, if we say, I don't know, 7, 7, 7 or 5, 5, 5. That would be another example of something like this. Whereas, again, 4, 4, 4, 6, 6, 6 would be another example of something like this. This proves here we didn't have to try out every single number. We could have, and that would make a good lesson. It would teach you something about numbers, I guess. But since we're taking a test, we only need 2 candidates. This one represents the even candidate. This one here represents the odd candidates. And again, since I said HHH, they're just asking us to squeeze in any one of those numbers into any non-zero digit. Divisible again. Obviously, I should have pointed out in the beginning. That means we have to divide. But I think you knew that part. Alright, let's take a look. This video is taking a bit longer than I thought. Alright, I want to tell you how these don't work. Alright, so you don't have to do this once you get your answer, really. You should feel satisfied, but just to please you, let's add another minute to this video. Another minute and a half. And try with this. Let's try with 5. That's a very sloppy 5. Forgive me for it. And here, 4. 20. 2 is the remainder. 2 doesn't go in, see? So that would have cancelled out that. Why did I cross out this 3? Someone tell me. I'm not paying attention, and you must always be attentive. So 3's our answer. We already know 3's our answer. I hope I made that really clear. I'm sorry if I didn't. We're just trying out these answers now just to show you how they don't work. So, by the way, if it doesn't work in one of them, it doesn't matter if it works in the other one. It's a matter of it working on both, alright? So, I'm sorry about the camera being blurry again. So, let's do 11 into this. Obviously, 11 goes into 22 twice. But it won't go into 2, obviously. And so, 11's not a candidate. 13 won't either. So, to not stretch this video too long, you just know it won't at a glance. The only number of all these that we tried that went into both 2, 2, 2 and 3, 3, 3 evenly was 3. So that's our answer. And that's G. And now you know. Again, it's all a matter of understanding what they're asking you. And the minute they ask you and you understand, then it just becomes a matter of doing the setup. The setup is this. Knowing that you should use an even number that's repeating and the non number that's repeating, and then dividing them by the candidates here, which are our choices, gives us the answer. Solid. Not knowing to do this and squeezing in too many numbers wastes time. Or not knowing to do it all obviously just leads you to get it incorrect. Unless you're lucky. Alright, until next time.